Hello and thank you for watching. I'm Angel Agüero and this is the video portion of my presentation, What's Your Angle? I will present to you some of the basic insights leading up to the concept of angle, as well as some of the exciting and fascinating results we can find using the angles and the ideas surrounding them. However, let me keep you no more. Let's get straight to the fun. Let me begin by introducing some possible notation I will be using throughout the video or in my oral presentation in front of the board. Some of it includes the symbol for, therefore. Also, you may see the backwards epsilon. This stands for such that. Also, this upside down T, which means perpendicular. We also have a less than with a little semicircle intersecting it, which is for angle. And finally, I may also be using the symbol, which is up like two L's, which stands for parallel. Okay, before we define angle, I'd like to mention a few preliminary remarks. The following items are the so-called primitive objects and are not formally defined, although we like to sometimes think of them as definitions. First, we may have something like a point. Here, point A. A point which is represented by a dot, has no length, width, or thickness. We may also have a line. A line can be represented by 2 points and has no width or thickness. Furthermore, a straight line is generated by a point always moving in the same direction. Or as I mentioned before, if we have 2 points B and we want to generate another line, it is without breadth in both directions. We also have some concept of ray. A ray is the part of the straight line beginning at a given point and extending limitlessly in one direction. For example, we may have a ray starting at, say, a point E, and then through some other point, and then extending indefinitely in another direction. Just a couple of remarks. We can't on our paper, for example, draw a line with just unlimited breadth in both directions. So if we are to write down on paper a line, we may have, for example, 2 points, and then we like to draw some line between it. And to denote this idea of going forever in both directions, we just tag on this 2 little arrows at the end of our segment. Now, for a ray, well, it's a similar idea. We do the beginning of our ray. They might go through another point, and we write our ray in the direction that it's going. And now, finally, we can define an angle. Well, what is an angle? Well, an angle is the figure formed by 2 rays with a common endpoint. Well, what does that mean? Well, that means if we have a ray, say, with one endpoint A going in the direction of, say, B, well, there would be another ray also sharing this common endpoint A in the direction of some other point, say, C. Now, this figure right here is our angle. Now, the rays AB and AC are the sides of the angle, while this endpoint A is its vertex. Now, the size of an angle depends on the extent to which one side of the angle must be rotated or turned about its vertex until it meets the other side. So what that means basically is we start at our base ray and then we rotate around until we reach the other ray, and that will give us an angle measure. To measure an angle, well, we may use a protractor or other means, but basically this is what the measure of an angle is. To make one remark, if we did go and measure an angle, and this rotation went all the way around, then one complete revolution is a total of 360 degrees. That means that 1/4 of a revolution, which would make a sharp corner or the corner of a box, is 90 degrees. And that has a name to it. No revolutions yields a zero angle. Of course, that's an angle that measures 0 degrees. An acute angle is one that measures less than 1/4 of a revolution of a circle, or less than 90 degrees. 90 degrees is a right angle. More than 90 degrees is an obtuse angle, but less than 180. A straight angle is exactly 180 degrees, which is what a straight line measures. A reflex angle is an angle that measures more than 180 degrees, but less than 360. That's roughly in this area right here. We are now ready, for example, to define the concept of, say, perpendicular lines. So given two lines or two segments, we could define another line or segment perpendicular to it. What that means is that these lines intersect at right angles. Each one of these angles is 90 degrees. And one of the things that this is most famously used in is in rectangular coordinates, which is what we probably will be working with in our class. And very exciting things to come in calculus and other like courses which take advantage of the power of Cartesian coordinates. Now, a few more key terms. Given two angles, say some angle A and some angle B, angle A is said to be congruent and written this way to angle B if and only if, by definition, the measurement of angle A is equal to the measurement of angle B. Also, adjacent angles are angles with a side in common. So for example, we may have two angles that have this side, say right here, in common. So this would be, say, some angle theta. This would be some angle beta. They have a common side, so they would be adjacent angles. Now, another idea is that of complementary angles. Complementary angles are angles whose measurements add up to 90 degrees. Two of them would make a right angle. So these two angles right here would be complementary angles. Keep in mind, though, that they must not necessarily be adjacent. Any two angles that add up to 90 degrees are complementary angles. There's also another idea, that of a supplementary angles. Supplementary angles, instead of 90 degrees, now add up to 180 degrees. to a straight angle. So here, angle alpha and angle beta are supplementary angles. Once again, they must not necessarily be adjacent for them to be supplementary. And then finally, what I'd like to say is that given two lines that are crossed by a transversal, dividing the lines into, or this plane into these many angles, angles 1, 2, 3, 4, 5, 6, 7, 8, then the following is true. Known as corresponding angles are angles 1 and 5. Also angles 2 and 6. Angles 3 and 7, and angles 4 and 8. So this 4 and 8 corresponding, 1 and 5, 2 and 6, 3 and 7. Also, we have what are known as alternate interior angles, and those would be angles 4 and angle 6 and angle 5 and angle 3. Those are important ideas that will come up really soon. Now, given those same angles, a postulate of geometry is that if two parallel lines are cut by a transversal, then corresponding angles are congruent. In other words, if these don't just happen to be any two lines cut by a transversal, but instead they are parallel and cut by a transversal, then corresponding angles are congruent. And now, for some fun in the nature of proof, to the board to prove to you that the sum of the measurements of the interior angles of a triangle is 180, as well as the vertical angles theorem, which says that vertical angles are always congruent. Now let's get straight to that fun. Thank you for listening to the video portion of the presentation.